2015 Entrepreneurial Engineering webinar series, where experts from the current Entrepreneurial Engineering Network and beyond are introducing tools and techniques and ideas that will help you further the development of entrepreneurial mindset in your students. The Kern Family Foundation has supported the work that you'll hear about today. I'm Doug Melton, and together with the presenters today and all that are participating on the webinar, let's unleash engineering. It's particularly exciting to see participants from the Keene network of partner of schools and associates from across engineering education. It's our desire to be inclusive and broadly share the work that's been done. So your active participation is critical. So if you're online, be prepared to form some questions for the presenters today. It will add to our recording that we're making. And today's webinar is brought to you from Lawrence Technological University in Southfield, Michigan, and we're joined by biomedical engineering professors Dr. Eric Myers and Dr. Mansoor Nasser. So they may further introduce themselves, but before we get started, this particular work is fostering the entrepreneurial mindset through development of multidisciplinary engineering learning modules based on the Quantified Self movement. That's a long title, but the thing to key in is around Quantified Self. You'll certainly hear more about that shortly. As the webinar proceeds, if you have questions, the presenters will pause at certain points. Type your questions into the chat box that's available in your control panel, and also within the window you may wish to adjust the frame that splits the window with the presentation and the video feed, so you can make some adjustments there to customize it. So without further ado, I introduce Eric Meyer and Mansoor Nasser.
Thank you very much, Doug, for inviting us.
Thank you.
Yeah, so we're very happy to be presenting this webinar. We've worked for about 1.5 years now on this project. We're both assistant professors, as he mentioned, in biomedical engineering. I teach more of the mechanical engineering type courses, the biomechanics and orthopedics courses. And
yeah, well, and I'm Mansoor, if you didn't know, I guess, and yes, but I teach the courses more on the biosensors and instrumentation side, and so, you know, let's begin.
Yeah, so really what we wanted to do, we think maybe some of the audience would be interested in proposing their own topical grants. So I attended a workshop at the fall meeting for Keene, where they basically taught people what they were looking for. And so the goal is to build up educational resources for entrepreneurial-minded learning and to expand a network of faculty within Keene who are interested in collaborating on developing these teaching modules or course modules and materials. So there were specific entrepreneurship skills that were targeted. If you haven't seen this chart before, it's the revised version for this year, but there's a lot of these materials available on the Keene website. And the focus, there were specific skills that were focused on. So in the opportunity column, things like identifying an opportunity, opportunity recognition, investigating the market, creating preliminary models, evaluating technical feasibility, and then also assessing regulatory and protecting intellectual property. I guess those are in the impact column, and communication. Those were some of the skills that we targeted in the modules that we created based on our proposal. And the other main ingredient of a proposal that would be funded is to have deliverables that you can share. So you have to be able to transfer what you're doing in your topical grant proposal to other people in the Keene network and beyond. So that was the idea of having collaborators. So we had other contributors from Lawrence Tech as well as other institutions, Kettering and Western New England, that took our modules, revised them for their own courses and programs, and then provided that information that we could disseminate. And so that's kind of what we're doing now. We also have some other a subnet and a roadshow that we're trying to promote this, as well as a website. So we're putting a lot of the materials on the website, and also publishing through American Society of Engineering Education as well. So those are the types of, and you can see the article that was in the Keynesian magazine as well. So, you know, for your proposal, just think about how you're going to market the resources that you develop, and get letters of support and that type of thing. You can actually find examples of these topical grant proposals on the Keen website, or you can contact them and they'd be happy to share our proposal with you.
Okay, so I'll take over here and maybe backtrack a little bit and sort of talk about exactly what happened with the, you know, everything that we've been doing. And I was talking with Eric right before we started that if, in a greater sense, what we've been doing is creating an ecosystem around a specific idea. And so, you know, it came about from a topical grant, but we've since done a lot of other things, and we've been really trying to disseminate and grow the, you know, the people that we've been collaborating with, in essence, to sort of, you know, to have a greater effect from the modules and the work that people have worked on. So I think the best thing to do is to sort of talk about this a little bit in a chronological fashion to see exactly how this came about. And I'll start with sort of a very personal view, which eventually I think resonated with other people within BME, which was the fact that when I joined Biomedical Engineering back in 2012 here at Lawrence Tech as a new faculty, I was assigned a few courses, and one of the courses that I was assigned was the senior project capstone that all seniors have to take before they can graduate. And what I noticed was after the first year of teaching was that the students had this tendency of coming up to faculty and just asking for ideas for project. You know, I want to do research with you. Do you have anything I can work on and stuff like that? And you know, I think that's pretty standard for a lot of institutions, and that worked to a large degree the way over here as well. But what we wanted to do was to get the students to start coming up with ideas themselves and identify the problems and know which people are being affected and go look out for these things themselves. But what we saw was that the only time they ever had a chance to do something like that in an important fashion was in their senior project. And so it came back to this idea about need to form habits, that if we wanted students to be able to do this, then we needed to provide them with opportunities to do this other than the senior projects. And so what came about between conversation between Eric and I was like, well, let's try to see if we can give some of these skills, which are really, if you think about it, based on the chart that Eric just showed, are entrepreneurial-minded learning skills, entrepreneurship skills, that the students needed to just have experienced before, just so that they can start thinking in this mode, which is otherwise very foreign to students in a traditional setting. So, so because of that, so we decided we were going to target some, you know, sophomore and junior level courses where we're going to introduce this stuff. And as Eric mentioned, you know, we had and we are very closely aligned with Keen's motto and Keen's view on entrepreneurship at Lawrence Tech. So we had the support, a mechanism for support, and we had the problem identified. The question was, how are we actually going to implement it? And what we decided to do was to use a particular theme and build all of our activities around there. And this theme is, in fact, quantified self. And so what I want to mention is that while you know, we talk a lot about quantified self, in the end, it is a tool to teach EML, entrepreneurial-minded learning, and skills that are associated with it. And in fact, if you go through it, I guess I'll explain the reasoning why we chose quantified self as the theme. But there are other themes that could be used. So we were interested in quantified self, and Eric will sort of explain what quantified self is in a few slides. But we were interested because to us it was something that was a very multifaceted area, something that could be approached from many different avenues and many different perspectives. So automatically it had that sort of scope built into it. Then the other thing was a lot of what quantified self is to do measurement of physiological data and personalized data, which is relevant from a biomedical engineering standpoint. And then from a real world perspective, there are actual products that allow you to measure data about yourself. So that gives it sort of that real world appeal. And so that's why, we said maybe the students will sort of latch onto that a lot more easily because they can see and touch and feel these products instead of just looking at them in a book somewhere. And then as I'll mention later on in the presentation, it has the capability of being extended beyond just the EML that what we have been primarily using it for as well. You can do more with it, and in fact that's one of the things that we're interested in taking it as well. Okay, so as I mentioned, it's a multifaceted problem. It's sort of a theme that we've used. I do want to mention that there are other themes that have been implemented and can be implemented. In fact, the quadcopter, as some of you know, Chris Kitts from Santa Clara University, he's been sort of building a lot of materials around, using quadcopters as a theme. And again, one of these open hardware type of modules with Arduino and sensors that can be built into it, that's another place where it can be used because it's a very multifaceted problem. So based on what your area of expertise is, you can use any of these themes. We just decided to go with quantified self. Okay, so specifically within BME, our plan was that we're going to have multiple experiences with EML. And so this is sort of my diagram of like a flow chart of what I envision, that initially we have these EML experiences that come every single year, but perhaps with the number of sides on these figures increasing, I guess what I'm trying to say is that maybe they would be at different levels of sophistication as well. So maybe at the freshman level, we'll introduce something that's not very involved, but by the time we go to senior level, we're introducing activities and modules that are a lot more involved. So this was our view of the how we're going to approach it at the biomedical engineering level. So introduce at least one course that had these modules in every single year during their during the 4 years of a biomedical engineering degree. Now, I want to take a little bit of a tangent here, and I guess it's a bit of a moment of pride for both Eric and I and people here in BME, because LTU as an institution, Lawrence Tech as an institution, has been working with Keen to try to develop this entrepreneurial-minded learning in general, through the whole engineering school. And in fact, I would say that we and the BME are at the forefront of it, having done something that was initially meant to be for BME is now something that's being sort of implemented across the whole college with other fields as well. So I think it's kind of nice because this is a fishbone chart that Tom DiAgostino, who's the person who's working on a sophomore level studio course that all engineers will have to take, and really whenever we talk about it, we've actually talked with them with what our view was for BME with EML, and how that sort of is in line with what we're trying to do with engineering in general. So I feel like this carries weight beyond just our BME program here. Okay, so I'll just show you this one slide, and then I'll hand it over to Eric again, which is that the quantified self I mentioned is a multifaceted problem, and so if you take a look at it, if you've known a little bit about it, but quantified self is self-knowledge through numbers. That's how it's been projected, and there's many different people who are involved in this ecosystem, and people who are from the computer science side with the sort of the data type issues. There's people in the game side who want to make it more user-friendly and interesting, and there's sensor technology and social networks. All of these are actually feeding into this quantified self. And so when I mentioned earlier that it's a multifaceted problem, this is one of the things that was exciting and interesting from us. And you can see many of these themes are very relevant for biomedical engineering too. So I think I've successfully avoided describing what quantified self is and sort of given you exactly what our motivation was for it. And now I'll let Eric sort of talk about exactly what specifically quantified self is.
Well, and maybe even before we jump into there, let me suggest to all the participants that are online, if you have questions at this time about anything that the presenters have talked about, this is a great time to type those into the box. Then I can field those and relay those to them. And I know there will be some questions, but let's go ahead and proceed, and we'll field those questions. But this is a great time to pause and get the participation of the audience. So,
thanks.
So yeah, just to reiterate with what Mansoor was saying, we thought that we could bring in faculty from electrical engineering and mechanical engineering, robotics and computer science and physiology, electrical engineering. We could really apply the modules that we developed into a number of different disciplines based on this multifaceted theme. Also, I called it a social movement. I'm not really sure that everybody would agree that it is a social movement, but there are certain people that are passionate about this. There's a great TED Talk by Gary Wolf, and you can see the reference for a New York Times article in 2010 that he wrote. So I actually show his video in class, and it really motivates this as a new and exciting social aspect that's an entrepreneurship opportunity. And so really what we're talking about is wearable sensors technology that helps people understand their health and wellness. And that can include things like sleep or fitness or even money or diet and mood tracking, all kinds of different issues. So for the people who are really passionate about it and are forming meetup groups throughout the country, there's actually one in the Detroit area here, where they kind of meet up through this website, Quantified Self. There's a couple different motivations. One, both of them revolve around the idea that traditionally health and wellness are top-down, where experts, researchers and clinicians tell people what they should be doing. You read it in books, and the expert tells you, how to follow a diet or a fitness training protocol. But with all these devices now, you can really do it yourself. You can learn what your body is. And this kind of grassroots model is more inspiring to not just the individuals, but also to families or communities to help people with challenges that they might have in their own life. And so part of what we've tried to do with the Topical grant is to find relevant examples that we can use in our class and then promote to other faculty members who are interested in using in this class. So there's all kinds of examples. Probably the most recent and well-known one is the Apple Watch, which is just coming out now, that measures all kinds of activity and things like that, but also does heart rate monitoring and things like that. So yeah, people are familiar with like Fitbit, but there's also concussion monitoring. There's the Athos is not really on the market yet either, but they're trying to monitor your muscle activity during exercise. Or Nike sensor monitors your acceleration in your shoe, but also your pressure in your shoe. Or there's training for golf swings or baseball swings or tennis swings. So there's really a wide variety of different sensors, that hardware that's available, and then there's also the software that goes along with it. But really, back to what this grant did is we would provide training to keen faculty so that they could implement modules in their courses, and we provide the material. And so the course modules that we've developed, we've created a website where we're sharing all of that material. So you can find our lecture slides, our assignments. There's a faculty instruction form, so you can actually see what the timeline was and our suggestions, and also assessment data. So we're still working on the website. We haven't uploaded all of the modules that have been developed so far, and in the future we're hoping to expand this to even more universities and faculty, and again, host all the materials on this website and provide it to Keen as well. So basically what we were trying to do is embed these modules into our core curriculum classes. So we weren't trying to do this in electives or trying to create new courses or anything like that. We identified courses that were required for all of our students, and then we tried to use the best pedagogical practices, things like active collaborative learning and problem-based learning that are inductive learning methods that students start with a real-world problem. We don't restrict the questions. Basically, we give them the theme, and then they kind of find their own information related to that theme using these active learning techniques. So you can see here, we did it in Intro to Biomedical Engineering, which is a freshman course, Biomedical Best Practices, which is a sophomore course that's more ethics and professionalism, and Medical Device Design, which is a junior level course that comes before senior projects. And then we also did an elective course in orthopedics, which I teach, that's really popular with our students. I think about half of our students actually take that course. And we also worked with collaborators, BME at Western New England. They have a sophomore fundamentals of biomedical engineering. And at Kettering University, the sophomore statics course in their mechanical engineering program. And then at Lawrence Tech, we did physiology laboratory, which is sophomore level, unified robotics 3, which is a junior level, and communication systems, which is the senior level course in biology, robotics, and electrical engineering. So what we're going to do for the remainder of the talk is describe 2 modules that we developed. So before we get to that, we can go back and answer any questions if we had any so far. And then basically I want to show you the lecture slides and describe some of the assignments and activities that we did with our students in at least 2 of these courses in biomedical engineering. So do we have any questions?
We do have a question, and maybe I'll take a couple of questions and combine them together. One of the things that was recognized that you recognized and you mentioned is that you're really just using this theme of quantified self as a vehicle for entrepreneurially minded learning. Themes come and go, so there's an appreciation of that notion that whether it's quadcopters or whether it's quantified self. So one question is, what are some other themes in the biomedical area that you see that could be a theme, or maybe for you it's the next topic after this one? So it's a little bit preliminary. The question might be a little bit preliminary because we haven't talked fully about this one, but let's entertain that question.
No, I think we've actually started talking about that already because we've been sort of trying to think about it, and I guess maybe I'll answer it briefly. Maybe it'll be a little bit better and understood a little bit later. But I think one of the things that's come out with the Quantified Self related activities is that some people want to do more. And we've been like, well, how can you extend that? And you can go to the slide that Eric showed before, which was the other theme. I'll put it up here just so that people can see. The thing on the right is this module with Arduino that have these Lego type modules that can be built into it. And a lot of these are sensors, in fact. And these sensors can measure sounds, and some of the more sophisticated ones can measure your heart rate and your temperature and body temperature and stuff. So in fact, it's a little bit less packaged like Quantified Self devices, which are very nice looking, and their product design to them. As you can see on these slides, these consumer devices, and most of these are in fact consumer devices, they've gone through a very rigorous process to make them look nice, so that the people would be appealing to them. But there is the next
and function user friendly.
I think I disagree with. Some of these are kind of like, I think, mainly just looking good, as we've seen in our experience. But students learn from that too, to see how functional they are. If you're a casual user, maybe the most important thing is the way it looks, and in fact that can be tied into an entrepreneur, sort of a theme, or like a entrepreneur skills, or some of those things that are in the chart as well. It's like, what makes something useful? So
well, maybe that ties into a kind of a related question on how are themes selected, and the questioner continues, I suppose engineering content and perceived student interest, but what else? What might prompt you to select a theme? And I'll offer this. I was looking at the IEEE Spectrum magazine, and IEEE Spectrum magazine talks about sweat of all things, and it talks about using sensors to measure sweat. And so just the fact that it's in here suggests it's a hot topic. That may be one of the reasons that themes are selected. But what are some other reasons?
Well, you asked for other examples, and I would say medical devices. A lot of programs use medical device. They have a course where they maybe have students interact with clinicians to develop new medical devices and that kind of thing. So medical devices is probably the more common approach for biomedical engineering, but it's maybe not as extendable to other disciplines in engineering. And you also have certain limitations for entrepreneurship in very tough regulatory issues that you have to deal with in order to get a product on the market. So the commercialization becomes a little bit more burdensome.
Yeah, I mean, if the idea is to just like involve a lot of people, then I think it needs to be something that's not so focused that people won't be able to sort of have a perspective on it. And so that's one of the things that I think is important for any theme, is that if you're going to get people involved from like art and design, and from it as we've done with like people from sciences and people from electrical engineering and some other places, and then I think it needs to have sort of at least some component that can be addressed by those people too. So it's not so focused on BME that other people are like, well, we can't do it. It's a closed system in that case. But yeah.
Well, I will suggest that the participants keep those questions coming in. We'll field those and relay those as you continue your presentation. Thank you.
So for our intro to biomedical engineering, this is a freshman course. So they don't have all of their technical skills or math skills or science experience. And so we wanted to kind of tailor it to that introductory level. And again, all of our modules encompassed in-class, active, collaborative teaching types of activities. And then they all revolved around this theme. So they were doing opportunity recognition using different brainstorming techniques like painstorming. That was something that we did in class. And then we followed that up with a more in-depth homework assignment. And then they came back into class and we did another follow-up active collaborative learning in class. And then we, gave them the next bit of the project. And so this continued over a number of weeks in some of these modules before they got to their final objective. So it was kind of like we were giving them the materials that they needed just in time. But we were doing it in class so everybody would kind of stay on the same page together. So we started with the investigation of quantified self devices, and I'll show you some of the slides that we used as we introduced that in this class. And then ultimately, their project was to use a Nike Plus shoe sensor in a new application. So this was actually with Chris Kitts at USC Santa Barbara. He provided these sensors that you see in the figure there, as well as kind of a task that students had to create a pitch video for a new idea revolving around this type of sensor. And we actually had fortunate to involve one of the Nike engineers who video chatted with our students during class to really set this up. It was kind of a failed product that Nike launched because maybe the opportunity wasn't very well defined, who their market was and what they were trying to do with this product. So the students had to go through the whole beginning stages and develop a preliminary prototype. They didn't have to build anything that worked, but they had to show what their concept was through a pitch video. So they uploaded these pitch videos to YouTube so we could kind of share them with the class. And there's a couple examples there. I can't show you the videos because it doesn't work very well over a webinar, but if you would like examples, I can definitely send them to you, so just contact us. But some of the videos were really good. Students kind of surprised us with their video editing capability and really their interest and passion for doing that type of creative process. The alternative was that they would just create some slides in PowerPoint and do a narration. You can record the slides and what you're saying about the slides as a video. So that was kind of, if they had no skills in video editing, they were still able to create these pitch videos. That's really an overview for that whole module. And again, all the materials are, all of these materials are on the Quantified Self for EML website that we have. So really, you know, we're introducing a survey of different biomedical engineering topics in this class. So we talk about biomechanics, we talk about biosensors, we talk about medical devices, and so this theme really relates a number of those different things. And there are a lot of, you know, issues of biomechanics in society. Students are familiar with playing video games using Kinect or Wii, or computer interactions with touch screens or with this new device called Leap that does markerless hand tracking. And quantified self could also be extended to biorobotics. So robots that mimic biological animals or other things like that, or that interact with humans, as with rehabilitation robotics or prosthetics. Those are all aspects that kind of tie in with the quantified self theme. For biosensors, there's a number of consumer products that use inertial sensors to do accelerometers or gyrometers or orientation sensors, you know, even in your phone. So your phone actually has an inertial sensor in it. There's also EMG sensors like this Myo wristband where you can do gestures with your hand and it's tracking the muscle activations in your forearm to detect, you know, what type of pointing and different wrist movements and finger movements that you're doing. Or the Nike shoe sensor was an example of measuring pressures in the shoe. And so I give them this slide. You know, we basically talk about a few examples in class. I also do a fitness network slide. Then the students have 5 or 10 minutes within their groups to go online and they have to find another example. So it's not just these examples. They can't use one of the examples that I provide. They have to find their own. And then they share it with their group. They find the most interesting one within their group, and then they present that to the class. So it's kind of a think, pair, share, active collaborative learning activity. And then we also talk about kind of this wider movement of what is a quantified self device? How is it different than a medical device? So here's an example of a medical device that records your ECG, and it could be stuck onto a patient in a hospital. But at the same time, there's another example of a sensor that would be put onto NBA basketball players during the game. And it's measuring the same things, but is it a medical device? No, it's a quantified self device. So what makes that different? Or another example, concussion monitoring. So this is a headband that has accelerometers and gyrometers in it to detect impact. And you can stream this information in real time to the sideline. You can track the entire team during a game. And if somebody suffers an impact that exceeds a threshold, you would pull them out to the sideline and have them assessed by an athletic trainer or a medical professional. So is this a FDA-approved medical device? No, it's not. And why is it not? So we have an opportunity to talk at a very freshman level. What is regulation for medical devices? What is the FDA? And that type of thing. And this is a slide that was provided by a guest speaker that we had come into class as well. So that's another thing. There's actually a lot of guest speakers that are available that could be related to this theme as well. Just in February, the FDA ruled on is the Apple Watch, all of these wearable sensors, should they be regulated as medical devices? And what they said was no, unless they're doing diagnosis or treatment, then they're consumer products, they're not medical devices, and the FDA is not interested in regulating them. So we can kind of describe that differentiation. And the other motivation, again, this is one of the slides that I'm motivating to the students with, is all of these ecosystems that Nike Plus, Apple with their health kit or research kit, these are software development kits or entrepreneurship programs that are sponsored by industry to get people to build new devices. So there's funding available, there's training available, and also in terms of this broader theme, health, digital health, the venture capital funding has really exploded in the past 5 years or so. So this digital health theme includes things like digital medical devices as well as quantified self devices like wearables and biosensing. So it, in 2003, was up to over $2 billion in venture capital, startup company funding, and 60% of the employees at these companies are engineers. So that's really motivating the keen idea that these are the engineers that are in demand working in this area. If we have any specific questions for that module, I have a lot more detail, but not enough time, so I had to cut things. But again, the website, or we're happy to share any information that we had for that.
We do have some questions for this particular segment, and if I pile these all together, it's basically what is the measure of success at a student level? Are there metrics? How often are they used? You talked about the need to form habits versus just collecting knowledge. And so how are you assessing that? Could you address that?
Well, I think so the assessment tools also become more sophisticated with the assignments that we give them. So at a freshman level where we're just sort of trying to get them to experience an area that from an industrial standpoint is experiencing is booming because with entrepreneurship. We just want to sort of them have plug in, and then at that point it's sort of up to the instructor in the case to see what's the quality of the video they've produced, or are they good at doing the assignments and they're turning them in on time, and maybe if the quality of writing or if their summaries or abstracts make sense.
One example for this course, they had to come up with a list of 20 opportunities for using the Nike shoe sensor in a new approach. I mean, just filling out a list. So that was the assignment. I gave them 20 lines. You have to come up with 20 ideas. And that's hard. Even our seniors struggle with brainstorming 20 ideas.
Any idea what the next step might be beyond just the creation of the possible list? How do you vet the quality of those? And we're trying to pursue opportunity recognition, and so coming up with quality opportunity recognition to move them forward in that.
Yeah. Well, I think the idea is that perhaps if they do this over and over again, you will see that in the next time around, you can actually then start to ask them, well, is your concept or the thing that you've highlighted, is it really feasible? You can start talking about issues of feasibility. You can start talking issues of, did you really go talk to a customer or something like this in this case? So I think that initially it needs to be something that just sort of get the engineers out of their shell to be able to be a little bit more, to be able to take risks, to come up with ideas, and so not that everything is, super calculated, but as they sort of build more of these, and you'll see in the next module that's coming up, that that's something that's for juniors and seniors, that now I start asking them questions which are much more involved, and now they have like a rubric and requirements that they have to actually abide by, and so there is a standard of quality that they have to meet.
Well, let's get to that. We've got about 10 more minutes of presentation, and then we'll follow up with 5 minutes of questions.
Sure, right. I'll go through this quickly. And again, Eric mentioned it. I know there's not enough time, but if somebody has interest beyond this webinar, then I'm more than happy to share this stuff. So now I'm going to talk about this course that used to be an elective course for BMEs, but now eventually we moved it as the sort of precursor to the senior projects, and so they take this in the junior year in the spring semester. Currently, I am teaching this right now, and in this, the course, it's mostly juniors who take it, but some of the seniors who wait until later they take it as well. And so, as I mentioned, it used to be elective, but now it's a required course because we want to give them this sort of a complete, going from a need to an idea sort of phase of these, the entrepreneurial sort of the whole process in this one course. And so what I do is basically do a bunch of the activities, that use some of these quantified self devices in classroom. And there are reasons for that. One, that traditionally when medical device classes have been taught, which are important because so many of the BMEs end up going and working for them, you're usually just teaching from a book because people don't have access to sophisticated medical devices unless you work with a hospital or you have a medical school, which a lot of universities don't. And so if I want to talk about an EKG device, either I need to invest a lot of money in a device, or what I can do is, well, here's the medical device part of it, and then if you look at it, you've got this handheld device, and this is a quantified self device. It also gives you an EKG. Then we can start talking about what is in one that makes it into a medical device and what is in the other that makes it into a consumer product. Same thing with this brainwave measurement, EEG, or electroencephalography. You can see the setup is very time-consuming and complex. And then we can sort of talk about working principles and how what is the electronics and things like that by using a very simple model that's shown on the right here with the lady who's wearing that headgear that uses just a single electrode. But students can now sort of look and feel something that they can actually use in class as well. We can start introduce issues of regulatory issues and intellectual property. For example, here are many different kinds of EEG devices that are on the on the market. All of these, except probably one, are consumer devices. And so the question is, well, what is the differentiator between these devices? So the students have to then maybe go back and take a look at it, and sort of, in a homework assignment, they might have to look at it and say, what are the capabilities of that? What is, the claim to fame for one of them as compared to the other? So these are sort of themes or things that happen in class continuously. And as I mentioned, we can talk about whether these are medical devices or consumer products, and you can talk about issues of labeling. What are the essential components? How can they be packaged so they're more user-friendly? I have examples of some of these devices that we get students to do homeworks with, or they'll gather some data with, and they get a chance to sort of use them. But the main activity that is happening in the class simultaneously, and it's a semester-long project, is that they basically have to then go back and, as they're learning about these consumer products, they have to actually come up and find a medical need, and they have to actually interact with the clinicians. So the whole gambit with the customer interaction and identifying the problem. And and then they eventually also have to generate a pitch video, but they also come up with, for example, a very preliminary product, like concept, like a design for it as well. So I'm showing a couple of things on the right that students have created. Some cannulated for device to measure if somebody's getting oxygen or not, with some kind of a heat sensors that's built in it. That's the one on the top. And then something that's a single device that allows you to cut an umbilical cord after a baby's born, and also leave it there so that there's lesser issues of contamination and sterilization in this case. So students came up with these themselves, and they went through a semester-long activity where they went and maybe even talked with clinicians and looked for devices that were out there to eventually come up with something like this. Now, I guess I want to mention that this is for medical device discoveries, but they're sort of getting motivated by quantified self type devices which they can use in class. So that sort of is like their form factor that they use for motivation, and then they use that to maybe come up with ideas for medical devices. So I think that's a and in fact the students want to do more. And this is to the question that Doug had mentioned earlier, where can you take it now? Well, you can in fact take a QS more towards the research side to see whether some of these devices can actually be used for data that's more robust. And there are open software development kits and open hardware that's available that can be used for research purposes. I'm showing one example that is again a brain activity monitoring device, but it comes with a very sophisticated software that allows you to now start measuring specific types of brain waves and frequencies and things like that. Something that for consumers wouldn't be useful, but now you can start doing research on that. And students want to do more. They are interested in there. So that was, I guess, the activity that was for the class. I just have a few more slides. Maybe in the interest of time, I'll just go through them, and then we'll just talk about open up for questions at the end. As to what we're doing right now. So we talked about the Topical grant that sort of motivated the modules, and we shared with you a couple of modules, and there's many more that were developed that we can share with you. And then what's happening right now? Well, so we sort of extended this Keen Topical grant with a Topical Network grant, which is another kind of grant that Keen offers. And the purpose for this is essentially dissemination and building a group of people. So now we're going beyond the initial collaborators that we had and trying to involve more people to sort of share this stuff with them, just like we're doing with you on this webinar. And the idea is that perhaps a larger community will be built around using this, and so we can pool our resources and be more effective, essentially. So that's this idea for the Keen grant. We've called it a roadshow because we've been actually taking the roadshow. We're going to take the roadshow to different network institutions and sort of showcase some of the stuff we've done and get people interested and perhaps get them on board to start developing similar stuff for their classes now. And that's why I guess this webinar is quite relevant as well, because it fits into that pretty well. In the short term, we just want to share stuff, but in the long term, this could be to build more collaborations as well as to do some scholarship and even research type work. As I mentioned, there's ability to do that. We had our first roadshow on LTU campus on April 24th, so just about a couple of weeks ago. And this is how we sort of structured it. We had an intro to QS, just like we did for you, a coursework example, just like we did for you again. And we had an industrial speaker who was a local entrepreneur who's been trying to commercialize his technology, come and give his perspective on it. And then we sort of did a mini workshop with some, hands-on stuff with people, some pictures and stuff. It was quite successful. We had 13 faculty members from Kettering and from UDM and Ohio Northern and LTU who attended this, as well as about 30 students who were present for this talk from, Dan Johnson, who works for this company called Exodynamics. They're trying to work, build a exoskeleton. And he's really going through a lot of stuff that we're teaching, but he's experiencing it as a person who's trying to do this in the, on the other side of the this, industry, and from the industrial standpoint. And so his perspective is very unique, and people enjoyed it. And then, as I mentioned, we've created material, some of which I know Doug has. We've created some brochure and pamphlet to promote and get people interested, as well as the website, which is the address is qs4eml.ltu.edu. You can access that. We've been sort of busy with the end of semester, so it hasn't been quite populated, but you can sort of see where we're going with there. This is just a screenshot of the front page in there. You can see we were trying to get people interested with the roadshow. And we're going to be doing a couple more of these, in a couple of other institutions. And we'll keep, people updated. So if you're interested, get in touch with us, and it's a good time to take any last questions and follow up.
We do have some questions. They're starting to pile on. We're getting some really good long questions that are going to be difficult to answer in the short time we have, but we're going to make an attempt to do so. First thing I want to note is that both of you are certainly entrepreneurial faculty members. I mean, you pursued these grant types. You have taken the initiative. You've taken the initiative to even create these materials. I've got one in hand that you showed on the screen that we love to see, and it's connected to even some of the work that was highlighted in Keensing, the article that was published about your work. So first of all, you're entrepreneurial faculty. The fact that you're going on a road show even underscores that. But here's the part that we love, and I think this ties into some of the questions. You've selected this theme of quantified self, and you're using it to stimulate curiosity about the topic so that students can kind of dive in and discover more,
yeah.
And it becomes their discovery process. You're helping them connect that to the meaning and what this has for society, for regulations, etc. So you're connecting this, and then what you're doing, I think, is creating value. You're helping them focus on creating value, and that's going to serve these students not just for a quantified self, but throughout. You're giving them educational experiences that will serve them and society throughout their career. Yeah. One of the questions that we have is, if you don't have these really attractive topics like quantified self, and you're working on statics or dynamics or circuits like I often have in the past, can we translate some of that? Do we see mechanisms to translate that to core courses? And we don't have much time. We only have about 1 or 2 minutes, so I'm just going to ask, keep the answers as brief as possible, but share your wisdom.
Mansur has a slightly different motivation for working on this project as the coordinator for senior projects, and he mentioned what that was. My motivation really stems from what we've been doing at Lawrence Tech. When I first started here, I was trained by, they call it the Keen Innovative Teaching Faculty, or KIT, on active collaborative learning, problem-based learning, methods for teaching. And so that's really what entrepreneurial-minded learning is as well. It's inductive learning, where it's not the traditional lecture, give students lots of example problems, and then a quiz or an exam. It doesn't follow that methodology where you give them the problem, you derive the equations, and then they have to memorize it, or just practice it a lot. So this is just a different way of teaching classes, where actually the best example, I think, is Pat Atkinson at Kettering, who did the statics module.
So it has been done in other classes too. I mean, you said statics is specifically one, but
yeah,
I've tried it in many other classes actually.
He actually kind of revamped his whole course and flipped it, but in a really interesting way, and then incorporated the module as well, really to do inductive learning, I would say. And so I'm kind of inspired by that. I can go back to my core courses, biomechanics and tissue mechanics, and I don't know about flipping it, but definitely try to do more inductive learning and real world problems rather than just problems from a textbook.
Well, I think what you have done, and we don't have any time left, but even your answer, Eric, should prompt our curiosity about some of the other things that are going on in the network that you have been involved in, both of you have been involved in. And so we thank you for the webinar, for these ideas, and really for the framing that you put around this that is so clear on how this is a vehicle, but the educational experiences you're providing are key, all for the benefit of the students that you see and that are seen across the network. So with that, we're going to close out today. Thank you both for that presentation. We have upcoming webinars even later today. So later today at 3 p.m. Eastern Time, Tom Kaiser of Western New England will discuss his topical grant work, including the voice of the customer in engineering product design. And then on May 13th, not too long from now, Ron Busanel of Union College will discuss his topical grant work, linking opportunity recognition, the value proposition, and customer segments. It's all great work going across the Keen network. Thank you both.
We want to thank Keen too. Thanks, Doug.
Thank you.
And all the other collaborators that are on the screen. And there's a lot of people who've made this work. We just are the people who usually talk about it. But there's a lot of people who've enabled it, and we want to acknowledge them too. So including.
So to all the participants as well, thanks so much, and we're signing off. Take care.